You're in an auto parts aisle, looking at rows of nearly identical plastic jugs. One costs $20, while another costs $45. This fluid enables thousands of metal components to move past each other at high speeds without grinding themselves to a halt. It carries away heat and suspends contaminants that would otherwise score the cylinder walls. The confusion starts when you check the labels. Both the budget and premium formulas often display the exact same viscosity and quality codes. For a standard commute in mild weather, both oils will keep the engine lubricated and running. The price gap represents the safety margins. You're paying for how the fluid behaves when the temperature drops to zero, or when the engine is pushed to its heat limits during a long climb. To understand which one you need, we have to examine the chemical differences between these bases and how they respond to different driving environments. Selecting the absolutely correct product requires aligning a specific chemical profile with the mechanical and financial reality of your car. Every motor oil begins with a base stock. This foundation dictates the fluid's baseline capabilities and how much it costs to produce. Conventional mineral oil is refined directly from crude oil. Because the refinement process is straightforward, conventional oil provides reliable lubrication for standard driving at the lowest possible cost. The trade-off is molecular consistency. Natural mineral oil molecules vary in size, which means the fluid breaks down faster under high heat and flows more slowly during a cold start. Full synthetic oils are different. These base stocks are engineered in a lab to ensure every single molecule is uniform in size and structure. That uniformity allows the oil to flow instantly on freezing mornings while maintaining a tougher protective film when the engine reaches its maximum operating temperature. The price you pay for that engineering is a higher investment at every single oil change. This table compares the 4 primary tiers against their source, flow, and cost. The data shows the synthetic premium buys a wider safe temperature band, protecting the engine where conventional oil struggles. Yet conventional oil is perfectly safe in mild climates with standard maintenance. Think of the premium price of synthetic as an insurance policy for extreme weather or high performance demands, rather than a requirement for every driver. There is a middle ground between these two extremes: synthetic blend oils. By mixing conventional and synthetic base stocks, these oils offer better temperature protection than standard mineral oil, but at a lower price point than a full synthetic. While it's a versatile compromise, a blend still lacks the total high-temperature stability of a pure synthetic base. The decision changes again once an engine passes 75,000 miles. Years of heat and friction cause internal rubber seals to dry out and shrink, which allows oil to slowly seep out of the engine. High-mileage oils are formulated to address this specific wear using unique additives and seal conditioners. These chemicals soak into the aging rubber, causing the seals to swell slightly and close off active leaks. If you are driving a newer vehicle with low mileage, these conditioners provide no extra mechanical value to your engine. You might be tempted to mix different oil grades or base types at home to save a few dollars, but that carries a high risk. Mixing formulas alters the carefully engineered viscosity of the fluid. This can lead to a thin lubrication film, poor cooling, and internal damage over time. Choosing an oil isn't about buying the most expensive option. It's about matching the chemistry to the current physical state of your engine. Regardless of the oil type you choose, you must first meet the non-negotiable requirements listed in your owner's manual. The first is the API rating, often shown as codes like SN or SP. This tells you the minimum performance category required for your engine's production year. The second is the SAE viscosity grade. These are the numbers on the front of the bottle that define how the oil flows at different temperatures. In a code like 5W30, the two numbers tell you how the fluid handles temperature extremes. The first number, followed by the W for winter, describes cold flow. A lower number means the oil reaches critical engine parts faster during a freezing start. The second number describes the viscosity at high operating temperatures. A higher number indicates the oil stays thicker and more protective when the engine is hot. If the oil doesn't match the manufacturer's recommended SAE or API specs, the engine will not be properly protected, even if you've spent the extra money on a premium synthetic. We can simplify the final choice by matching your specific profile to the correct formulation. This framework starts by confirming your manual's requirements, then branches based on your mileage and the stress of your local climate. First is the budget commuter. This is for drivers in mild climates who use their vehicles for standard daily driving and want to minimize maintenance costs. Conventional or synthetic blend oils are the correct match here. They provide the necessary protection without the extra cost of a full synthetic. Next is the extreme driver. This applies if you face freezing winters, intense summer heat, or operate a modern turbocharged engine. You should use full synthetic. The higher cost is an investment in the safety margins required for those high-stress conditions. Finally, the aging fleet profile covers any vehicle with over 75,000 miles on the odometer. A high-mileage formula is the preventative choice. The seal conditioners are necessary to keep the aging gaskets flexible and prevent leaks. Selecting the optimal formulation requires balancing the manufacturer's standards against your climate and the current wear on your odometer.